All right, how about a little quick trivia for Bitcoins? In the movie Sneakers, what is the name of the character that Dan Aykroyd plays? Nope. Who said it? All right, Bitcoins. Blink. Let's see, let me find another one. Okay, all right. In the movie Back to the Future, what was the name of the school principal who was played during both Marty and his parents' school days? Anyone? The principal's name. Back to the Future. Come on. I thought this was a... Okay, who said Strickland first? Somebody. Oh, you guys don't count. You guys... I'm just kidding. All right, well, you're going to have to come find John for a Bitcoin then.
I know John. That's my guy.
Let me try. All right, I'm going to introduce our next speakers. Our next talk is called Movement After Initial Compromise. We have two speakers. Matt is a red team security engineer conducting red team operations and penetration tests for 6th Gen. He has 7 years of experience in the information security field and operated on an NSA certified DoD red team. He's also a U.S. Marine Corps veteran that specialized in signal intelligence. Thanks to our veterans. And also Colin Hartley. Colin is a persistent cyber operator for NSA certified DoD red team. Enough said. Thanks, guys.
All right. Like you said, our talk's on movement after initial compromise. Harley and I met. He was he's still active duty. He can't say where he's currently working right now. But I was a contractor there, and we hit it off, and I learned a lot from him. I hope he's learned some from me, and we've worked together for a while now. I left him to work at 6th Gen, but I'm saying that's us because we're both newbies and we're babies. It's our first time presenting, and we've gone to a few conferences, and a lot of people spoke about a lot of things we're talking about, and then they didn't have video examples, and they didn't go into some of the detail that I wanted. So we only have 45 minutes. We can't deep dive super deep into all of them, but I hope that people learn a lot and take a lot from the information. All right. So my name is Matt Batten. I go by SleepZ3R0, which there's two meanings. So in Cobalt Strike, that means interactive mode. If anybody uses Cobalt Strike, which is a C2, right? Command control. And it also means I don't sleep a lot. And then I have a GitHub. I've created some Python scripts for logging of Cobalt Strike as well. It'll take it all and then output it to CSV. And you can import it into whatever you want. And it's super useful. You can edit it to do whatever you want, utilize it however you want. So I currently work at 6th Gen. It's the best company and job I've ever had. My team's amazing, all brilliant minds, and they really look out for me, and I'm just super happy. I get to work from home too, which is really nice. It's a big plus. So my husband, I was recently married in May, and red teamer, pen tester, develop, and like you said, Marine Corps vet, and also cat dad. And so there's my wife hugging R2D2. Thought it was funny. Us married. I don't know if she knew I was putting this picture in there, but it made me really happy and pissed her off. She's up there, so it's funny. And then there's my cat. Always looks pissed off when I drink coffee. I love dogs too, but yeah, it's true. It's probably get to work. All right. So.
My name is Colin Hartley. As you can tell by the spelling of Colin, I normally just go by Hartley because of the military and because it's hard to understand. I'm an NSA certified red teamer and active duty military. I promise I'm not spying on you or in your computers. I promise that. I'm not married, but I'm an older brother. I take pride in my little sisters. Red teamer and penetration tester. He's the cat man. I'm the dog man. And moving forward.
All right, so what we're going to cover is initial recon once on a compromised system. So once you get that initial callback, what you're going to do immediately after. We're going to talk about lateral movement, so how to move to other systems once you're on that network. Port forwarding, so how to send data through a system that you've already compromised to make it look like it comes from the compromised system to the target, so they don't see your attack machine, right? Your attack platform. You want to hide yourself. How to utilize tradecraft, not get caught while moving. So a lot of stuff we're showing you. The tradecraft isn't, top notch. There's more involved, like utilizing like invoke cradle crafter, like invoke obfuscation to obfuscate your PowerShell one-liner, like stuff like that. Like not just running, your UPX against or whatever. But this will give you a good baseline if you're new into getting a red team, or if you're a blue teamer trying to understand what red teamers are doing. I think this will help out a lot. And what tools are being used today? All right. So setting the stage. So we're saying that you already compromised the system. So most likely it was a phishing email or it was physical access, right? Everyone brags and talks about it normally. So they utilize a rubber ducky or a bash bunny. Rubber ducky is seen as a keyboard they plug into USB that most likely will execute PowerShell one-liner or whatever you set it as, that will call out to your C2, which is a command control that you would then connect to from your attack platform. And then you can say whatever you want through the shell that you now have access to. Example would be, I've heard a lot and I've seen is they speak to a secretary, will say the secretary's name's Bob. Bob, I need access to these servers. You're not on the list. How do I get on the list? Sarah, the IT director, has to put you on the list. What's Sarah's last name? Smith. Sarah Smith. Can I get your business card, Bob? Sure. You take the business card, you step out, you take a picture, send it to an operator in a hotel room. You go back in. By that time, he's already sent an email to her or to him as Sarah, stating that you get access to the servers because he already has a system that he compromised inside and knows their mail server. And it's really easy to send a spoofed email. So then she gives me access, and I just plug a bash bunny in every system I see, right? And yeah. So first things first, you're on the system. Who am I? I thought it was really deep. It's a really deep question. So who am I on the network? Where am I in this network? Can I move my current permissions? How do I get system? So like system's gonna be like your highest level permission on the box that you're on, the machine you're on. Obviously you want to get administrator like domain admin is probably your end goal depending on what you want to do. And but getting systems, important so you can steal processes on your current machine. Hopefully you have that opportunity. An example that I like to say is utilizing these commands is really important because what if the target machine you're on is not within the scope of the network you're attacking? What if like when I was taking OSCP, a lot of times I actually exploited my own box, and I just got excited. I got a shell, and I would just start running commands. And then 20 minutes later, I realized that I was running all those tools and attacks on my own Kali VM. And a lot of people aren't honest about that, and I'm very truthful about when I mess up. So that happened quite a lot, and I learned a lot from it though, and that's why these commands are important. All right.
So kind of going into what Matt just said, we're going to go into some commands that can answer those questions, right? You will see later on in the talk that we do have the outputs and us actually running these on a target system through our C2. So some commands I like to talk on are net group domain admin / domain. Like he said, system is the highest privilege you can get, but that's on the local system itself. Your end goal is going to be exploiting one of those domain admin systems so you can move to the DC or wherever you want on the network. They have high permissions, and on top of that, it can go pretty much anywhere they want. Another one's going to be like net user / domain, shows you the users on the domain. It's not as important as domain admins, but still they have the ability to move to whatever computer they want to. Next slide. Okay. This is just another list of commands like ipconfig, like in his OCP example, if he would have ran ipconfig within his his box or ifconfig, he would have been able to see the IP address was not his target host. So if he saw that, then he would save the time he ran all those other tools, exploits, and commands. The next one is going to be who am I? This would have told him right away also who he was on the network, who he was on the target, and when he got the output back, he would have known that he wasn't who he desired. Okay, like I said before, we're going to show you some of the outputs of the commands. Like in the top right, net group domain admin / domain. As you see in our network, we're Batman fans, so our domain admin is going to be Joker for our sandbox environment. Net group domain is going to show you the domains that are on the domain itself. On the left here, we have net start. This is just going to show you the Windows services that are ran on startup that are started. And then net local group / domain is going to show the local groups actually on the domain itself. Top left, this is actually one of my favorite recon commands, netstack, tac ANO. A is for TCP and UDP. It's going to show both protocols. N is going to put them in numerical value by port. And then O is going to show you the PID it's running at. So if you know, like, you've been compromised, you've been caught, and you're trying to get off the system, you can see our connection right there is running under PID 3344, I believe. And we can go in and kill that process so they won't see that we have an active connection to the target host.
Is there? Nothing's plugged in. Oh, my bad. So again, NetSH firewall show config. You can see if something's like operation mode, it's disabled. You can get a lot of more information about your firewall. Your route print, you can see all the pathways, right? You can see your gateway and all that. Task list, it's going to show all the service information for each process, right? Your process ID and everything. Driver query, that's a really important one. You can actually do a driver query /B, and then it's FO/FO space CSV, and you can carry it out. And you can actually get a whole list of all the drivers for like future post exploitation. You can mess with that data. So ARP TAC A, so address resolution protocol, TAC A is for all. So it's looking at your ARP cache of systems it's previously seen. Your set command shows you all your environmental variables. So the reason, like, if I'm on a target, I just run set right away normally instead of doing a system info because I'm lazy. I don't want to wait for all that data. And I just want to see domain controller right away. I'm like, what's the DC? Set. Boom. There's a DC. I know that. Schedule task, it's going to show you all schedule tasks. The /B is going to, verbose, it's going to show you more information so you actually know what user that schedule task is running under as, which that's important information for future you, right? Yeah. Oh yeah, it's more. So disrespect your surroundings. But who am I? So who am I on the network? So I'm Cave Batman, right? Echo logon server, that's another command I run, usually right off the get-go, but NL test is going to probably work better. So you want to get the DC, but due to configuration changes on the domain controller or just the Active Directory in general can affect that. So you want to do it's a NL test ds-git domain name. But if you just do an NL test help, you can actually see that, and that'll give you the DC right away. All right, that's you.
So our first demonstration, we've now at this point in the test, we have pretty much who we are, where we are, what we're operating against. So now, in order to start the lateral movement, we're going to run Powersploit, and a module within that is called Power Up. This is going to do invoke all checks on a target system, and this will give us the ability to actually see if there's any method. If there's any method for privilege escalation right off the bat. Okay, so all of our commands are going to be typed into the bottom left corner. Right now we're doing a PowerShell tech import because obviously we want to import our PowerShell script that we're going to end up running against the target machine. Powersploit is the tool suite. Within there, what do you want to accomplish? Privesc is what we want to accomplish at this point. And then what we want to use to accomplish that, we're going to run powerup.ps1. So now that that's uploaded to Cobalt Strike, we're then going to do PowerShell invoke tac all checks. And what this is going to run, you're going to see it blow by pretty quick. It's going to go through a list of set checks that it will look for misconfigurations on the network that it can take advantage of to cause that privilege escalation. What you're going to see blow by here in a second, we do scroll back up to it. It's a ability to do a DL hijacking attack. It's a very common attack used for privilege escalation. What I like about PowerUp is it gives you the abuse function. So you have your right tac hijack DLL commandlet and the DLL path that you're going to want to take over in order to complete your attack. It gives you it right on the screen. So all you have to do is copy and paste. When you're talking about PowerUp, you have to have Goku because that's 13 episodes deep of him trying to go Saiyan. But PowerUp has a built-in module for DLL hijacking. You saw us use the right tac hijack DLL. What that does is it creates a self-deleting batch file on the target with the command you want to run for privilege escalation. You can alter it and change it. And then it creates, using C++, DLL and replaces the hijackable DLL and then runs it. And once that runs, it calls your batch file that you have, and after it runs, you get your privilege escalated beacon back. It will self-delete, so there won't be trace of it, unless they're doing active logging of their DLL DLL edits, and batch files in the system.
So going to WMIC, so there's a bunch of ways to do remote code execution. There's great examples online as well, and we're just going to go over a few of them. So that's a Windows Management Instrumentation console. So it's a way of utilizing WMI to get remote code execution of a payload that you already hit on a target for persistence, or possibly you want to move to that target, right? So this is obviously an example for Cobalt Strike. We're going to do some Metasploit examples later on as well in other commands. So there's a turtle.exe that I put in the system32 directory on the target machine, right? So obviously I wouldn't actually name this turtle in a real operation. I would name it something that's already on there, and then I would put 32 at the end of it. I would append 32 or something so it doesn't stand out, and I would timestamp it so they would have the same time as another executable or DL or whatever I put on the target, right? So you see turtle.exe's in there. So currently I'm on the .12. And you can see I'm an administrator. My process is 5796, and I'm going to run a remote dir. So I'm actually dirring it remotely to make sure my executable is there before I just kick off a WMIC command against the target, because I don't want unnecessary traffic. Even though remotely dirring does add more traffic, obviously, but I don't want to try to call something with WMIC when it's not actually there. So I remotely dir it. I scroll up, I see it's there. Yay. Boom. There's my turtle.exe. I know it's a executable, it's payload. And I know when I execute it that I will get a shell from that target machine. What is it? So we always start shell commands because it's through command prompt, right? It's Windows native. You can do PowerShell and other stuff as well, but the node, you classify, or you say your target's IP address. So I'm moving to the .8. So something to think about here is when I do this, it's going to take me a second to realize because I used a SMB link, or I'm linking it with SMB, and the reason I'm utilizing SMB instead of just 443 or 80, right? So 443 is encrypted, yes. 80 is another way to get the callback, but you can use SMB because it goes over wherever. I specified a random high port for this specific one, but SMB is usually over 445, right? Your domain controller speaks over SMB to all the other systems, so because I'm targeting the domain controller to get that callback, you don't want traffic going out 443 or 80 because a good blue team or a good network security team at a company would see that weird traffic. And you'll see a beacon call in a minute, or I should link to it. So it's a binding. It's an SMB bind, so I actually have to link to the target IP. So there's a link. So now it's actually going through my initial beacon to the target, and so that way all the traffic's not 80 or 443, because a lot of times you'll see a lot of operators, as soon as they get access to a DC or get those credentials, they get excited and they just run 443 or 80 because they just, they'll kick it off and they want that callback. But you need to use SMB, or you can do DNS tunneling as well. It's another way, because 53, right? Because everything speaks over 53 in SMB. All right. Sorry.
Going into another type of remote code execution, one thing I want to state is all these types of remote code execution lateral movement are either through stuff that's natively on Windows or within sysinternal suite, which is a Windows side executable. So we're using stuff that's already there on the system machine. We're not just downloading and uploading large amounts of data and payloads to the system itself. So this is going to be a scheduled tasks. As you said, shell we're doing within Cobalt Strike again. So /create, that pretty much explains itself. We're going to be creating a schedule in the target system. Task name is going to be mat.exe. You guys are going to see a lot of mat.exe and a lot of stuff named Matt because he's all about himself. Joke. But the task you want to run is going to be mat.exe in this case. We're going to run it once. There's many different ones you can decide to do. You can do it on idle, on startup, run it once. You can state a time. And so you can actually use this as a method of persistence if you know that there's not a lot of traffic at a certain time of day. Kill it at the end of their workday, and then when they come back in at 7:30, your task kicks off, you get your callback, and you can kind of blend in with the network to a certain degree. So here's going to be an example of us actually running a sketch task on a target system. Again, we're going to go shell sketch task. We're going to run the command I read to you previously. Create task name. In this case, it won't be Matt. It's going to be turtle. The task run is going to be the turtle.exe we previously utilized in our previous attacks. Since we're gonna kick it off ourselves, we're just gonna run it once, and we're not gonna specify a time. So after we kick it off this one time to start, we're not gonna utilize this anymore, just for the sake of example. And we want to run it under system, right? So when we get this callback, since we're going from administrator on this target machine, we're going to run as system, so our beacon should call back as system. Next, we are actually kicking off the scheduled task ourselves. So /run, task name again, turtle. So we know the task is on the compromised system. We're going to the .8 again and specifying the task to run. Okay, success, the scheduled task turtle has successfully been created. You're not going to want to run the command to execute it, obviously, before you get that confirmation message that it's been created. So again, there you go. What I like is it gives you that success back. Success, it's going to attempt to run the scheduled task. Cobalt Strike is very friendly with giving you your syntax errors back pretty quickly and not letting you run faulty commands or commands with wrong syntax against a target system. Okay, and once we are doing, so we have a couple of our videos, we're running SMB links still because we're exploiting the domain controller. So a little bit of times we pause and wait to link it. So as you see, we link it. Now we have system on the Joker, the .8, and we're going through our .12. So the DC isn't going to be seeing our Kali attack box on the backside. It'll just be seeing traffic from, a host on our network's communicating to the domain controller via port 445 or the random hive port we specified. The final thing we're going to do, obviously because we don't want it there, we didn't use it for persistence in this case, we're going to delete it. /f is force. Delete is what we want to do. And we're going to delete the task that we created and on the target we created. If you delete the task itself, it's not going to kill your beacon. So you will have opportunities to interact with your beacon as long as you want that day. But the next day you will have to create a new task or move a payload over. The last form of remote code execution I'm going into right now is a service create, another thing that's used natively on Windows. So the command here with a service create, we're going to obviously want to know our target. Create, here we go with Matt again. And then we have our bin path, stands for binary path, and this is just path to your executable on the target machine. And then for this, once you create the service, we're going to kick it off ourselves, and then make sure we delete it again, for tradecraft, so you're not just leaving started services and leaving scheduled tasks running, because those are easy to query for a blue teamer on the other side. Okay. So right now we're interacting with the .12 again. We're going to be targeting the .8 in this example, just because it's our domain controller. We want to show that it works from host to domain controller, and the payload will run on different boxes. So right now we're going to service create. There's our target, the .8 again. That's going to be the domain controller Joker. This time he named it I Love Baby Turtles. And bin path is going to be obviously the path to the executable we had on the target already. This time we put the payload in Windows temp. A good thing, what I like about Windows temp is that it's created like on logon, and when the person logs off or system's rebooted, temp will be wiped, so you won't leave your executables on the target for a very long amount of time. It's a kind of way to, even if you do forget to remove it yourself, it will be deleted, so you kind of like CYA a little bit. Okay. This one did take a minute to come back, so it should give us the service create, like the success message, just letting us know that it's been created on the target box. I love even when we're in interactive mode, it still takes a long amount of time to call back to our C2. There we go, our create service success. So we know the service is created on that target. And so now we know that we can move forward on our test, and we can actually try to kick off the service itself. So there we go, service create. This is us remotely kicking off our service on the .8 again. We want to start it, obviously start, stop. It's pretty self-explanatory. And I Love Baby Turtles, that's the service we created. So if you put spaces in the I Love Baby Turtles or any of your service create, you're going to have to actually wrap that in quotes because it won't read it. We got really impatient here because we didn't wait for the success message, so we just kept trying to link to it, and the fourth time was a charm. It ended up kicking back a system, which is what we wanted to run it under. As you use Joker, there's our process ID, our callback time, and our SMB link to the DC. What I like about Cobalt Strike is everything's very visual, and you get the command line access as well, because the SMB link on the top left, if it breaks or the callback dies while you're on the target, that link in the chain will visually break on your screen. It'll be separated. Also, what I like about the SMB links is the SMB links only call back when you have traffic and input to give the target host. So it's not constantly going to and from. You're not constantly seeing that activity and that traffic. You're just going to see data being given back to you when you're actually running and trying to exploit the target or exfil data. So just because we had a lot of Cobalt Strike to start, we're going to add some interpreter in there for people who are enjoying interpreter or using MSF console. So we're just going to do Psexec. So here we go. We're going to load our actual module itself, Windows SMB Psexec. Obviously, when you're doing interpreter, the nice thing they have is show options, so it tells you what's required. Our port, we're doing SMB, which works with Psexec. So that's already set for us. So all we have to do is set our R host. This is, again, what goes into exploiting our own box. We accidentally set the R host to .12. So if we would have ran this, we would have ran it against yourself. Look kind of goofy. So, make sure we had it right. Change it to the .8. We had credentials at this point. So we set our SMB user and our SMB password. You don't have to, but if you have it, it won't hurt you to use. Run show options again to make sure nothing has been reverted to default and all of your options are set in the exploit itself. And then you can type run or exploit. Either way, it will run for you. As you see at the bottom, obviously you don't want to do port 4444. That's common with interpreter. You're going to want to specify your own port, but for the sake of the demo, we left it by default. You're going to see the interpreter session start up, and then you're going to want to do get UID because you want to see who we are. You want to answer those questions that we asked in the beginning of the talk. A process was created. We go down and run hostname because once you're an interpreter, you can go inside a shell. As you see, we're on the Microsoft Corporation, all rights reserved, so we're within a Windows box. We have our hostname Joker, which has been the .8, and now we know where we are and we have our ability to start interacting as a shell or use other interpreter payloads and modules against the target.
Okay. So we have to mention WINrm for lateral movement or moving within the network, right? So it's Windows Remote Management. So it's on port 595, 5986. 5986 is encrypted. A lot of people will argue, and I know that encrypted traffic can be sent over 5985. I'm aware, and it's just another good way to laterally move. And Windows Server 2008, same thing. It's a WRS now. It's just something to be familiar with and know that's already it's on the Windows targets. And I love that meme because it's true. Windows Server Security, keep out or enter. I'm a sign, not a cop. That's very true. And then so next one's a remote registry. So registry keys, right? There's just a dude running with a register. So I put a goat.exe on a remote or a target machine on the desktop just so you can see it. Obviously, I wouldn't do that on a real operation again, but it's for pictures and stuff. So remote registry has to be enabled on the target under your services, right? So if you see that's enabled, then you can move as well. So for this one, I use interpreter, and so I already have a shell, and I'm going to add a registry key to a remote machine. And then I'm going to kick it off so that I get a callback from it. And I ended up using the same payload that I originally had this interpreter session on. That's why I'm going to kill my session before the callback. So there it is. I added it. So I'm going after the Batman computer. So that's a .12. So my attack machine is .6. I already have a shell from .10. And I'm going after .12, which is the Batman. So Batman com, that's the registry key location, right? I called it wolf. I'm calling on the goat.exe. And so after it runs, what I'm doing here is I'm shutting down, or I'm restarting the system remotely. So I added that registry key to the .12, and now to get that registry key to kick off, I restart the target machine. So it's a shutdown, /m, and then I'm calling on that system through the host name, right? And then TACRFT, so time0, do it now. Force, right? So I restarted the target box. I killed my session because my payload's about to kick off, and I started my listener. So there's my listener. So my callback's calling to the .6. I'm waiting. I'm then going to show you that the target machine, what the user sees when I execute this, right? It takes me a second because I'm slow in videos, apparently. But it's a lot faster when we rehearse, right? But the video is going to come up, the target. So there's my VM, which is the target, go.exe. And then you're going to see me capture, the shell's going to come in. So it's already restarted. I should have pulled it up earlier. And boom, shell.12, right? So now I have access to that system. And that's what a user would see if they were like currently on. They would see the box restart, and then we would just have a shell and be able to do whatever we want. And from that point, establish persistence, hide stuff in there, and laterally move. You don't stay on the box once you initially compromise it. Yep. All right. DCOM. So DCOM's super technical and in depth. So Matt Nelson's the one who documented it. I just want you guys to be aware that it is a way to do lateral movement. I don't think I'm by far like the expert to speak on DCOM, but it's really important. There's a lot of good resources out there to perform it. All right. Oh, yeah, just you.
So I'm sure everyone here has heard of Mimikatz. It's a thing that's been on AV, been flagged on HBSS and on boxes for a long time now. We're just going to go over a method how we've experienced and we've ran on tests where we don't have to put anything involving Mimikatz on the actual target box. We're just going to use a sysinternal suite, which is Windows Sign, Psexec in there. We have, in this case, we're going to be using procdump, right? So once we notice that they have sysinternals downloaded on the target host, we're going to use procdump, as you see in the top left-hand screenshot, to target LSAS. LSAS is what Mimikatz targets because that is where the passwords are going to be stored. The SHA-1 hashes, NTLM hashes, passwords are going to be stored since the last reboot of this machine. So what we're going to do is when we have procdump, we're going to leverage it to target lsas.exe, and the give me you see right beside lsas.exe is the name of our mini dump file. This is pretty much going to be the output of the process LSAS, so we can then pull it down to our target Windows attack platform. And when you're doing this, make sure that your Windows attack platform is the same architecture and same year as the target host you're going after. If not, it will not work. So once we have our mini dump in the bottom left hand corner and Mimikatz, we have also you see on our desktop in the bottom left hand corner. We're going to run mimikatz.exe, and then you're going to see we're going to take our mini dump file, import it. It's going to say giveme.dmp, and then we're going to run sec urlsa log on passwords, and it's just against the giveme.dmp, the mini dump file, and then we're going to see the output. There's a very long list of users, so if you kept scrolling down on the screenshot, we had a limited amount of space. You will see clear text passwords. Here you get to see the domain, the username, the NTLM, and SHA-1 hash of the target, of the administrator itself. And this is actually really nice because you're not using Mimikatz maliciously at all on the target system. When me and Matt originally started working together, when I was the experienced one and he was the newbie, this is how he first got domain admin on his first domain controller.
So, I'll say a quick story because it's pretty cool, and I think it teaches people a lot of stuff. So I ended up getting default credentials to RDP to a target, which is like super bad tradecraft if you think about it, but it was the only way I could get on that system at the time. And then I couldn't use WMIC or get remote code execution on any of the targets I wanted. I saw a file server I really wanted. I knew a domain admin had logged into it. So I thought about it, and I didn't think it would work. And it was pretty ghetto. And it's funny, though. It was I RDP'd through RDP, and I mapped my share. I moved Windows sysinternal suite to the target, the file server, and then proc dumped the LSAS and created the mini dump file, and then pulled everything back. So everything's Windows signed, so nothing malicious. It doesn't look malicious at all to anyone, because the sysads were using RDP. So unless somebody was on while I was on, then that would have been bad. But I pulled the dump file back, and the reason he said the architecture matters is because it actually took me a few hours, which is embarrassing again. Like I admit, when it takes me a while, it was a x86 target, and I pulled it back at a 64 Kali, and I sat there. I kept running Mimikatz with mini dump, and I realized I had to move to another system or a new attack platform to then get the creds. And then I got domain admin. I'll never forget that. It was the first time. It was really humbling and fun. So, all right. Oh yeah, still me. All right. Responder. You can't talk about lateral movement and moving around network without responder, right? Super important, super in depth. There's a lot of information. So I love Responder. It's a lot of fun. Any company you ever go to, if you get access to a switch, if you ever walk in there, depending on their port security and everything, they'll never have a lockout when you pull the Ethernet out on the first try. Normally, somebody in here will argue with me after, I'm sure, but most likely network engineers are lazier in that, and they don't want, if something like comes unplugged, not be able to just plug back in and redo everything. So A lot of times when I've done pen tests, I'll go up to a switch, and then we have port security, and I'll just unplug the Ethernet from the switch. I'll plug it in my attack machine, right, my laptop, and I'll do a TCP dump or Wireshark, and I capture their IP address and their MAC. I clone my MAC, I clone my IP address. I then plug into the switch. They're the Ethernet port that I pulled the original one from with my attack machine because I'm now that machine. And then I would run responder, right? And the reason I'm running responder is to capture hashes that are pass or sent across traffic, right? So LMMNR, it's link local, multicast, name resolution, and NetBIOS name server is what the other one is, which that just they're pretty much the same thing. Just NetBIOS name server runs on IPv4. So here's an example of me capturing a hash from a target user. So what's going to happen here is the target is going to try to access a network resource that isn't actually available. So food, right? I was really hungry, I think, when I was in this video. So I try to get a food, and it doesn't exist. And because it doesn't exist, it means it's not in the DNS, right? It's going to query. It's going to, hey, DNS, is that there? No. And I'm going to be like, yeah, that's me. Send me your hash. And the computer's going to be like, oh shit. Oh, sorry, language. Oh yeah, that's me. That's me. And then, dang. And then I get so then he'll send me his username and hash, and I can take that hash offline and try to crack it. You can do a lot of things with it. I have an example later. I'm going to utilize multi-relay. My first script I've ever wrote that I was super proud of was automation of ByteBleeder's tool, which was a responder to crack map exec to NTM relay, and then a PowerShell one-liner, and I just got shells. Horrible tradecraft. It was super cool. So there's a user and the hash, right? That's what everybody wants. You pull that offline, you can crack it, you can pass hash, all this stuff. Run finger.py, right, Python. The reason for this tool is to see see what domain and see if SMB signing and see the OS version of the target. So when you run that, you're gonna actually see. I'm gonna run against the 3 machines in my lab environment. You're gonna see on .8 SMB signing is true, so responder's not gonna work against that. So I'm sure everyone here for their company, they have SMB signing on their network, which is a joke because a lot of people have legacy systems and they can't due to Samba and Linux, but so responder will work. So multi-relay, it's an amazing tool for NTL1 v2, right? And it'll do HTTP and like nothing like if you have automatic proxy set in your if you have your proxy set to automatic for your WPAD on your browsers, right, for your images, then you're open to WPAD, which you can actually force WPAD in your responder, which just means that certain resources that you try to access to the internet, when they query it, I would just say, yeah, that's me, same thing, get the hash. So you don't want automatic set in your browsers through your image. You want to go back and set that manually. And here's an example. So this is a .12, again, I know you probably can't see that. So it's a .12, the Batman target, and the user's administrator. And actually, I'm gonna start over. So important, you have to turn off SMB and HTTP in the responder.configuration file.conf, and that's so that you don't have protocol conflicts, right? So you're gonna turn those 2 off because multi-relay is gonna be utilizing that, right? Not responder, but so you're gonna start responder, or I'm gonna set multi-relay first. So in multi-relay, you can do attack. You can do the target, so you can specify multiple targets or a range, or you can specify one. So say you're going after one machine, then you can specify user, you can specify all users. So for this example, I'm saying I want this guy, and I'm only going to use this user. Or I'm going to use all users, sorry. This guy, I'm going to use all users. So anybody that passes their hash, any users, I'm just going to relay it to that target to try to get a shell. Which the shell is the end goal here, right? And hold on. So here's me starting responder. I think I'm going to try to go to a share called hi everyone, which doesn't exist. Okay. So it's listening. I know it's listening. I know multi-relay is currently running as well. And then I'm going to go to hi everyone. I don't know, it's horrible. You can't read that. But so I try to go to hi everyone. Boom, shell. Right, I can dump hashes. I can get over interpreter, or Cobalt Strike, whatever I want, whatever C2 I want to do. So responder is really useful.
Next, one of the last things we're going to is going to be port forwarding. There's many different types of port forwarding. We mostly go into proxy chains port forwarding, SOCKS with Cobalt Strike, and then Metasploit port forwarding. The good thing about port forwarding is it's it's not like the SMB links we were having earlier. This is using a compromised host to tunnel traffic through. Yes, you're doing that when you push a payload, obviously through SMB link, but this is just for anything you want to run from your Kali box. So in our examples, we're doing scans of a target system from a system within the internal network, so we can see what ports are open on it and anything we can target. So the first video is going to be proxy chains with port forwarding with SOCKS through Cobalt Strike. The file on the right I'm editing is proxychains.conf. As you see in the bottom, there's our attack box IP, port 8000. And then in Cobalt Strike, we're going to do SOCKS and then make sure the port links up. So everything on port 8000 is going to be given through Cobalt Strike. It's going to go through our beacon that we have on the .12. And then for proof of concept, we're running proxy chains nmap, just an nmap scan. So we're going to be scanning I believe we're scanning the .10, the Batman box, or the .10, the Robin box from our .12. So if you're running packet capture or Wireshark, you're not going to be seeing that nmap scan coming from our .6 or Kali box outside your network. You're going to see it internal, if you are in fact running it. So we're looking for ports 22, 445, or 3389. As you see, 445 is open, and 3389 with RDP and 22 SH is closed, which is good for a sysadmin, but Eternal Blue can target SMB 445, so we can leverage that using pushing exploits through our port forwarding to target the end host, so we can move further into the network. Okay. Port forwarding through Interpreter. At the top, you're going to see us. Obviously, we have to create our payload. We're using MSF Venom to create our payload in this one. TechP is the payload. We're using reverse TCP. Our host is going to have to match up. Everything in the payload is going to have to match up with everything on our listener. So our Kali box is listening on port 8686. TechF is the format to executable. cat.exe is the executable itself we're creating. And then we're setting up our multi-handler, which is our listener, just to catch that callback once we run it on a remote host. The next slide. This is important because especially if you have insider threat or someone on the internal network, we're using Python, a TechM module, simple HTTP server on port 8080 to host our etc TechF directory. That's where we're holding our cat.exe exploit that we want to put on the host box. So say you have someone insider threat or a cat team or someone that goes out, they can browse to our 192.168.1.6 on 8080 and they can see that executable. Depending on the security settings of the target network, they can download that and execute it and give us our callback back. As you see the GET request on the left-hand side, they are hitting our attack box from the victim. This is just showing you us running our multi-handler. So we're running our listener, and we kicked off cat.exe on the target box. We just did proof of concept within shell to show you our host name is Robin. And then we exited out of the shell and straightened back into our interpreter session, which is where you have to run the port forward add. And as you saw, based on our nmap scan using SOCKS proxy earlier, we're targeting the 445 on the .12, so we can then go exploit that because we saw that port 445 was open.
So there's obviously experts on Bloodhound. I'm sure everybody's aware of this and knows what it is, but we can't talk about it without touching it again, right? So Bloodhound utilizes Neo4j, right, which is a graph database management platform. And that's us logging our Neo4j server on the bottom left, server connect, right? This is Bloodhound bouncing just ahead. It's cute. Thought it was funny. No one laughs. It's fine. So it's important. So you start your Neo4j server. And the coolest part of this, right? So if you've worked with Bloodhound, you've seen this. So Bloodhound runs, it gathers all the user data, and you get the groups and the users. You know the shortest path to your domain admin or getting to whatever group you want, right? But a lot of people, so it drops the zip. So it actually drops the zip file to the target, and you pull those back, and you upload the CSVs, the Neo4j. You can actually, they actually set it up now where you can do a reverse port forward, and using it's like REST API or like the URI, right? It's like TAC URI. You specify your username and password, or TAC URI, you specify your path, so HTTP 127.0.0.1, 7474, whatever, 76, something like that. You can actually have all the data go directly in your Neo4j from your target, so you don't have to drop that zip on a target. And that's pretty fun and pretty cool. So you can see your Neo4j just updating. You can do a loop as well, right? Looping is really important because you don't know how much data is going and when the users are active. So that's the zip that I dropped on target because. And there's an example of what it looks like. So this is the shortest path to the high value targets, right? Yellow's the groups, green's the users, and then the red's the box we compromise. And it's super pretty. Those guys are brilliant, obviously. And now we're at the end. So like I have to do references because I don't want to say all this information is mine because it's all out there. And these guys are, again, brilliant. And I love learning from them and just being around them. So all these websites are super useful. And you should visit them all. Spectre Officer, they're awesome. And then people that have influenced us, and they might not even realize it. So I had to put their Twitter handles, handles, because I follow them super closely. I read all their posts, and they're super inspirational to me. They don't realize it probably, so I'm just watching them from afar. I'm creeping on them, but it's weird. I met a few of these guys. They're awesome. And there's Dwight. I love The Office again. And like that's what I imagine a hacker on a network is just like domain admin, network engineer, whatever. Like just the same person, just a bunch of different hats. And I thought it was pretty funny. Again, Dwight. But if you enjoyed this talk, like to know more, that's why I did the reference slide. That's why we put the Twitter handles up there. And that's why we're saying message us on Twitter. I love feedback and I love getting questions and just moving forward with other people and like collaborating. I write in Python. I'm currently working on writing my own implants. And the big thing, so to finish up, something I want to mention is a lot of stuff we talked about was Cobalt Strike and Metasploit, but for those super awesome red teams out there, they're creating their own C2s and their own implants. And that's how they're not, AV is not going to detect that because they're just crawling all those signatures. As soon as Cobalt Strike comes out with a new version, they just, they buy it. Or they'll upgrade their version and then they just crawl it and then they update the signatures and then you're going to get flagged. So it's great that we're utilizing this and it sounds really cool, but creating your own and keeping it in-house is the way to go long-term. That's going to cost a lot of money up front for development for companies, so just so you know. And, do you have anything? That's our talk. We're right at 0. Does anyone have questions, I guess? Sorry. Good? Sorry. Oh, shit.
Questions? We got a couple seconds.
So you're speaking about systems other than like just basic Windows and Linux systems, right? And how secure are they? So generally if they have an OS, we are Linux and Windows. Oh, sorry. We are Windows and Linux, like that's our niche and that's what we go to when it comes to exploitation. But there's people out there that can exploit anything from like the kernels on like the Windows and Kali boxes, or they can do server-side exploits, or they can do web-based applications. I'm sure if it's connected to any network on the internet, there's someone out there that has an exploit for it or can target it in a way. We just are Kali Windows and Windows Legacy based when it comes to attackers.
Yeah. Any more? Also, like nothing's really secure depending on like the value. That's like a huge thing. So like if it's super valuable, then yeah, somebody's going after it, and you're not secure. And like it's better to look for already being compromised than to just assume that no one will come after you. Right. Yeah. Right. All right. Any more questions? Sorry. No. Cool. Yeah, man. If you follow us on Twitter, no, I'm saying, but we're going to post them. I wish that I already uploaded them all before. I should have uploaded them before this. I believe, are you guys going to post the slide? No? Yeah. Okay. So they're going to post slides as well for BsidesRDU. And that's why I made these slides so people can use them. That's the thing, like, we went to a bunch of talks. People spoke about this stuff, responder, pass the hash, all this, port forwarding. Like, port forwarding blew my mind the first time I learned it. Like, I was like, I don't understand. So I'm attacking myself, and then it's hitting things, and it's working. I have a shell that's not me, and so no, these shells will be available. We'll post them on Twitter or slides. Shells. Talking about hacking all day. All right, cool. Is that it? Sorry. All right. Have a good one. Nice being on y'all.